Previous session we discussed over here till here. So creating a new type with a field like this, uh, creating one more struct inside another struct. This is what we have done. Yeah, and also we printed. So we have created another type called address, and then we used that particular address inside another type called employee. Fine. So then another example, stub, I can say, okay, there is a concept called promoted fields actually. A promoted field, I will explain right now. So, uh, see, if you create a type, let's say maybe type same employee or a student, struct student has got a number, name, and email, something called status for fields. I purposely wrote like this also you can write or like individually also you can write. And student has got an address, maybe line 1, city, state, country, and pin code. So I want to utilize student in sorry address type inside the student. Okay, let me put the same thing. Let me go back to the previous example. I just would like to pick something called address. Okay, I put address method. Address method is going to print the address display. Sorry, display is the method. It's going to print the display. Okay, display the address. Okay, I also would like to print the function s student display. Let's say number s dot number email name status. Now there is a concept called promoted field. If you look at previous example, this is how we have created a field. Okay, there is a field name and field type. Field name and field type. The concept of this is not a promoted field. This is using a struct. The concept of promoted field is you use field type. That's it. You just use field type. You don't use field name, which is called promoted field, which we call it as a promoted field. Promoted field means you just use field type. You do not use field name. What is the use of this? There is kind of a use something like in inheritance. I cannot exactly say inheritance, but there is a uh, feature. It can be used like inheritance. Let's say that I would like to create a new function new student. I give number, name, email, status as string, and here I pass address, address. So return. So here I got to create a new student. Return student of number, name, email, address. Okay, I got to create a new student. This is the details of the student. Let me go and create a student s1 equal to new student of, maybe I give a number, I give a name, and here I have to pass the new address, so I can directly pass address of line 1 equal to uh, maybe right. I pass address. Fine, it looks okay. What is the difference right now? But if you look at S1 dot, I told you bit kind of an inheritance. If you look at S1 dot, you see that you got city, you got country, email, sorry, email, however, you get pin code and all directly with S1. So you get directly with S1. Okay. That's what the promoted field. That means you can get access to the methods and fields of this particular type directly with this particular object. For example, I want to get the for example, I want to get the address. For example, I want to print the let's say the display method. Okay, here unfortunately it's not fortunately or unfortunately it's like student. Let me print the city. Okay, from the dot print line city is I don't need to do s1 dot address dot city. I can do, but I don't need to do directly. I can say s1 dot city. I can directly say s1 dot city. See that. which is called a promoted field. Promoted field means you can access the promoted field means you can access the members means fields and then methods of the promoted field type directly. That's what you can do. You can directly call the promoted field types. You can directly access the members of the field directly without calling. But here there is some kind of a contradiction because display is the method which is available for a student as well as even for the address. At that time, yes, there is some ambiguity. Let's say s1 dot, you want to call the method or field which is already available, same name with address, and then also with the student, then of course you have to call display. For example, s1 dot address dot display. You have to call the display if you want to call the display of address and the display of student. There is an ambiguity. Since there is an ambiguity, you have to call them with the type. Okay. No, no, no. Promoted field means it's not same. Promoted field means you can directly access. Just give don't give the name of the type. Promoted field composition is different. Composition is you are just using like a normal field. But promoted field means you don't give the name of the field. Okay, you just directly give the field. Composition means you give the name of the field. Okay, you give the name of the field, but promoted field you don't give the name of the field. You directly give the field. What is the use of that is it works similar to inheritance. Okay, it works similar to inheritance. It works similar to it's not inheritance. Again, I don't say that it is inheritance since there is no concept of inheritance, but it works somewhere near to inheritance because directly you can access the fields of this promoted field with the actual type of the promoted type fields or methods whatever with the actual type. You see that s1 dot city. For example, if you go here, I want to say e2 dot, you don't get city. E2 dot address dot city you have to use because it's not a promoted field, it's a normal field. Okay, but here you can directly access s1 dot city, s1 dot line 1. Again, if the same field is used both the areas, same field or method, of course you have to call with specifically with the type. Otherwise, not required. You can directly use the field. That is what the promoted field is. Okay. What is the use of that? There are so many uses of promoted fields. You can achieve kind of an inheritance. As I said again, there is no concept of inheritance. We can just think of somewhat that it's actually a separate concept. I cannot say that it is inheritance. The concept itself is called promoted field. So I don't. But just for your understanding, I am saying it is somewhat related to similar to inheritance, but there is no concept of inheritance. Okay, we call it as a promoted field. Fine. Let's go to the another example. Copy or stub 42 as user defined types of embedded struct is something. You can create a struct You can create a struct. Let's say I directly use this, and I can create a new struct or directly over here instead of line line one as line one comma let's say city, state, country, pin code. The This is called an embedded struct. You're directly creating the struct inside the another struct, directly creating the struct. You see that this is very important syntax because you can also create a variable rather than a struct. I will show you later on. This is called the embedding a struct. There are so many variations, and I am trying to explain these variations. You may come across your code that with the different variations. You shouldn't be confused. If you really look at here, you should be able to understand that this is called the concept is called promoted field. Okay, the concept is called promoted field, and then if you create something like this, then you should be able to understand this is an embedded struct. You can do that technically, but you cannot attach directly methods over here. The reason is you can't write methods. You can't write methods directly. Fine. Let me create uh, a display method. Let me go copy over here instead of writing everything. I just copy from here. Display. Okay, you cannot go and then create like this. Let's say I want to display the address as well. Okay, but there is nothing called address, and you cannot create like this as well. You cannot create like this. But how can you access them? Because you cannot attach a method to address. How can I access them? Here you have to access. Uh, you have to access this way. That means s dot line one, s dot in fact address dot line one, s dot address dot city, s dot address dot state. If you Because it's just a normal, looks like a normal field, but you cannot attach methods here. But you can create your entity, or you can model your the thing like this as a separate struct, which is an embedding a struct existing struct, embedding a struct inside another struct. Earlier you were calling it as a field, but here you are embedding a struct. It can go to any level. Let's say I want to create a social media. You can create a new struct. Okay, instead of student, let me put it as a person. Okay, person. I want to put it as something called social media over here. Then, maybe Twitter, and then maybe LinkedIn, etc. I can directly go here, fmt.println. Twitter is s dot social media dot Twitter. You want to put the LinkedIn s dot social media dot LinkedIn. You feel like it's S doesn't make sense. You can put it as a P, and then you can S dot put it as P dot. Like that you can embed any number of structs, You can embed any number of, you can embed anything. Here also you can create a separate type as social media and then you can put it as a promoted field or you can put it as a, let's say if I put the same thing over here as a promoted field. So whenever I print it over here, S is a student. Let's say I want to print social media over here. Okay, I can directly put S dot. If I use it as a promoted field, S dot Twitter, and then S dot LinkedIn directly, I can use. Okay, let me go to first of all 41 executed. So it is giving memory segmentation violation error. The reason is segmentation violation error you are getting. You put it as a pointer over here, and then you're trying to directly call the details, but this is nil. This is nil. So either you always check if it is not nil. If s dot social media not equal to nil, then only print it because the moment you start using pointers, this is the problem. Okay, and then here also you assign values something called social media, and then you give social media details. Here also uh, social media. You want to give it here, and this is how you print after that. While you're assigning values, either you can put it like this. Let's say Twitter equal to, for example, that is the Twitter handle, LinkedIn equal to. So this is how you can give as a normal thing. Here you are accessing as in promoted field. It's a promoted field. But when it comes to here, okay, you are directly using it as an embedded field. Let's say I create a new function. Okay, here I create a new function, new person. So this is the new type. You see that you cannot go and put a concrete type over here. So I'll write it and show you. I want to create a new function new person. So what does the person has? Name, email, and status. Name, email, status as string. There is no problem. But the second field is a type. So you have to pass it like a variable. This has to be passed as a variable. And the third one is in another type. Uh, Probably you can put small letters, that is fine. So this is going to return a new person. So I'm going to return as a new return person of, you know, that there is a name, name go as a name, email, email, status, status, and the address go as address, social media, social media. You can directly pass them like this. But what is the difference? Here there is no a type. There is no concrete type. There is a embedded type. You just created a type over there and then you are passing values to that particular type. So let's say P1 equal to new person of, I give my name, I give status, and here this is the tricky part because there is no special field that you have to create. There is no special field that you have to create. So what happened? You have to create the field because it's a field. The whole thing itself is a field. Okay, you need to create a structure with that particular form and then pass the values over there. Let's say line 1, maybe A, B, C, D line, and then you have to pass the city, maybe Dubai, state, Dubai, country, UAE. There is no pin code over there, but okay, pin code 971, for example. You see that this, and then you have to pass the another type called social media. This got to be the type. So Twitter equal to GTNP, LinkedIn equal to, so like this you have to pass P1, and then of course you can pass P1 dot display. Again you want to pass the fields P1 dot address dot, because it's because there is the type of the field itself is an address. Inside that these are, so P1 P person dot address dot person dot social media. So there is a difference between embedded struct, a normal struct, and also the promoted field. Promoted field means you can directly access through P1. Normal struct means you can access, but here you cannot attach methods because this is a embedded struct, a struct that you are creating inside the another struct directly. So you cannot go and then create a method for special. You can create methods. You can attach methods only for person, but you cannot attach methods for address. It's it's quite difficult. It's quite not difficult. It's quite different. Okay. This is how you can do that. Okay. Fine. This is how you can create. Let's say you want to create something called P2, for example, not with a new function. I would like to create as a person. You can create as person. Let's say you can create it as name, email. If you are not using new function, I'm telling status, and here address. So how the address is a separate structure. Okay, separate structure. So you have to pass a structure like this. You have to pass as a structure like this. Address. Okay, this got to be the address. And social media, you pass social media. For example, your You're not creating with a new function, but you are just creating p2 dot display. Okay, p2 dot display. You can also create something like p3 equal to new built-in function of person. P3 is a new built-in function of person. Okay. Then you can see p3 dot name like that. You can give p3 dot. Here also you can give after assigning these values. You can give if you want. Still you can give p2 dot name equal to, maybe I give Jitin p I want to give. Then I can call again display. You can access, this is the initial values you are giving. But here, if you are accessing giving like this, you have to especially give p3 dot. You can directly access name equal to Jitin, etc. Let me put it as different names. Rahim. Okay. Okay. Now I have 42. I'm sorry, it is 42. I can, so this got as Priya, and then the third one I have not called display p3 dot display. So if you don't give values of the type, okay, the zero values are given. See, I just gave it as Rahim. Uh, okay, these are the rest of the things are zero values, because zero values means you have not given any values to the third type, because you use it as a built-in function using new built-in function. You know what is the use of a built-in function? It will create a person, and then it creates a pointer. P3 is a pointer. Okay, that's how you can. So I'm just showing three ways to create. This is the general standard way people write new kind of a constructor function. It's a function, but it acts as a constructor, and then you can create like this. Okay, cool. Now, these are three types. One is promoted field. Promoted field. Today, what we discussed especially about a promoted field. Sorry, this is not a promoted field. Uh, Promoted field. That means you don't give any name of the field. That means directly you can access the members. Members means fields as well as methods. Okay, generally in object-oriented programming, we call them as members. But in Go, you can say fields and methods. But directly you can access fields and methods directly with the name of the object. Okay, s1.city, s1.country, even though it is inside the another type called address, you can directly call student dot, you know student dot line one, student city, student dot state, etc. You can directly call them. This is called promoted field. Okay, social media also. This is one variation. Okay, the other one is you can directly create them as a structure inside this particular type. You can directly create them as a structure inside this particular type. This is the another variation where you can go and then create a structure, and then you can directly call them. But how you call them is very important, because this is the whole thing is a variable. You have to pass it as a variable. You have to pass it as a variable and assign values. I'll show you another way as well. I'll show you, but right now please keep it like this. Fine. Now I just want to create a new type. Let's say mkdir 43. Uh, sorry, it's not mkdir. Copy or stub 43 user defined type with any. Okay, let's say it's 43 user defined type as any. I can copy paste most of the code, but just explaining, so that you can carefully observe. If I type and all, it gives you some idea. Type, let's say person, struct. I have name, email, status, and then I just put it as details as any. You see that person details as any. You know that what is any? Any means any kind of type. The moment you put any, you can give any type, any value. This is very, very important. Can give, can assign any kind of value. This is pretty tricky part. Okay, fine. Fine. Let's first create the P1. I have not created any kind of new function. If you want, you can create a new function. Function new person. Say I give name, email, status, and then details as details. Sorry, as any. It going to return person, and of course you put it as return person of name, email, status, and details as details. This is any. Remember that this is any. Now let's see. I create P1 shorthand declaration of new person of. I give my name. I give my email. I give some status. And here technically what it is any. It is any. Any means I can pass any details. It's not necessarily to be one value. Any I give it as, oh, let me give it as, okay, Bangalore 1 India 560086. What is any here? Any is just a string. Details are just a string. Details are just a string. So fmt.println, I have not created any display function. You'll see later on. I just put it as P1. So it got to print whatever the P1 is, it prints the P1. I didn't write any display method. Fine. Now I create something called P2 as a new person of, maybe let me create it as, and here it goes. you got a person, you got you give details, and here the details is any. That means you can pass any. So what I do is I create a struct, I give the details, line 1, uh, city, pin code, and I assign values, line 1 equal to Bangalore, for example, 1, city is, sorry, maybe city is Bangalore, and then pin code is 560086. You see that? So if you see that, since it is any, you can pass any details. Here you directly pass it as a string. Here you are creating as an embedded structure variable. It's a variable. Basically, it's not as embedded structure. It's a variable. You're passing data. So I can print fmt dot println p2. Let's say I create p3, new person, uh, all the details I give, maybe Raja, active, and here I give struct of Twitter, LinkedIn, and then I pass the values Twitter, LinkedIn, for example. Since since this is any, you can technically pass any details. You can pass any kind of details. Any can be anything. It can be a struct, it can be even a function actually. I'll show you later on, but right now it can be a struct, it can be a function, it can be an interface, it can be anything basically. So here two struct variables I got, and then three variables I have created, and then three different types of details I pass. Three different types of variables details I pass. Okay, three types of variables I pass because it's any. So now what I want you to do is I want to create create a display function. If any is a type of a struct with line 1 city and then pin code, print that. If any is a type of struct Twitter, LinkedIn, print that. If any is not of those two types, print nothing with respect to details. For example, this is what we have to do. So take some 10 minutes of time, try to do that. I will explain what I do. I'll push the code first, git add, I push the details. Uh, you can have a look at it. So I want you to implement that. Okay, I want you to three. Let's say I want to write a display method as I uh, requested here, as I said here. I want to write a display method. Okay, let me write a display display. Generally, I can sorry, I can display person details. So fmt dot println name name of a person. It goes as p dot name, and I get email, and I get status. Here comes to the actual thing. So any is the field. The moment we start working with any field, the moment we start working with any field, here the kind of requirement is if any is, so what I said, if any is this, you have to print these details. If any is this, we have to print these details. If any is not other than these two, then I don't need to print any details, for example. So the moment you try to work with any, you're specifically checking the type. The moment you start checking the type, you can use type switch. For what you have to use type switch, p dot details dot type. This is the type switch. P dot details is any, p dot details is any dot type, what type it belongs to, which is called a type switch. So what type, if how should I print the type? If you really carefully look at this one, and this one, for your understanding, fmt dot println type of p1 details, if you really look at it, reflect dot type of p1 dot details. I'm just I'm just printing this for your understanding. Let's say for p2 details, let's say for p3 details, p2, p3. I know what type these are. This is for you to understand what type actually p1 dot details, what type it is. It is string. P2 dot details, what type it is. It is actually, this is the type. The whole thing is the type. P3 dot details, what type it is. The whole thing is the type. Let me put it as a new line so that it's not required this much of data space. If you really look at it, type of p1 dot details is string. Type of p2 dot details type of p2 dot details is this is the type, and then type of p3 dot details, and this is the type. This is a type. Remember that this is a type. It is a type. So what I do is I go and then go here. I don't want to really deal with string. Okay. If you want, you can add, but just my requirement is only to check the type of struct and all. So case followed by the type. What is the type? The type is struct of this one. If the type is struct of this one, maybe I can put it as T1. Then fmt.println line 1 equal to T1 dot line 1 city pin code city pin code. If this is the type. What if the type is this? This is a type. Remember that that is a type. That's how the type is. Case this, then this is the type. These two types only I want to print the display method. String, what for example, you also want to print string, then you have to say case string when the type is string fmt.println. Okay, just to put details of t1 dot t1. That's it. It's just a string. This is how you have to check. So this is a type. For example, let's say I have got a type. I have got a concrete type. Let's say because details can be given anything. Technically, for details you can give anything. Let me create a new type called uh, mailers. Contact is details. Okay, contact is a type. I give WhatsApp, and then I know WhatsApp is a email, not email already have mobile number and telephone, which is a type. I have contacts, WhatsApp, mobile, and telephone. I have three. It's a concrete type. Since the details is any, I can also give this contact concrete type. Let's say I give something called P4, P4 equal to new person of, I give maybe, okay, PS is the name, for example, ps@gmail.com, active, and here the details, since it's a details is any, I can create the contact as well. WhatsApp is maybe 9618550011. and what else? WhatsApp and mobile, maybe same details. Maybe mobile number I give this. Telephone 040123456 for example. Okay, I print fmt dot. So now how can I catch this? Now p4 dot details is of a type called contact. The moment you come here, then case I have to give contact because that's the type. Uh, and then you print the details. This is how you call this. Let's say p4 dot instead of print line over here. Sorry, instead of print line over here, I can say p1 dot display, p2 dot display, p3 dot display, and p4 dot display. The screen may not be sufficient to display all the things, but yeah. Okay. Now go run. See that this is p1. You got the details which is of a string. p2, you know, p2 percent. Let me see what I did. I'm just still printing p2. p1. Okay, p2 dot display. I p2 dot display p3 dot type. Okay, p4 dot display. So this got to be the p1. This got to be the p2. This is the type information, and then you see that line, city, pin code. p3 street children LinkedIn. p4 you could see these details, telephone, mobile, and etc. Fine. What if I create p5 new person and give a new type, struct of maybe blog. You see that if you get call a blog and then I say p5 dot display, this would not print this information. The reason is this type is not captured over here. You have not captured this type. So blog information would not be printed over there. Okay, for now, I just park it aside. I park it aside because I would not be having space to show. So you see that only three details are shown. The blocked information is not shown. The reason is that is not captured since it is any, and that is not captured over here. Okay. So generally in Go language, there is a concept of generics. Uh, with the version 1.18 onwards, Go started supporting generics, but still people use any very regularly, very uh, rigorously. People use any. Any is very efficient type. Any is still type safe. Okay, sorry. Statically typed. Any is also statically typed. Even though any looks that it's going to store any kind of data, it is statically typed. That is something that we need to understand. It is statically typed. Any is statically typed. Why it is statically typed? All the types information is loaded during compilation time itself. Then it cross checks whether the type is already existed or not. It's not like Python and all at runtime it tries to evaluate the type information. Even though we are trying to assign a value to any, a variable of type called any, there are some compilation checks. That is something we need to, it's not a dynamically checked. It is at compile time it is checked because the compiler goes and cross checks whether the type that you are going to use to any is existed in the system or not. Then only it accepts it. So it is type safe. Even you are using any, it is type safe. Okay, contact would not be printed over here. I'll write it down. Contact does not print contact since contact is not captured. I'm sorry, it's not contact, it's a block since the type is not checked in type switch. This is what the concept. Okay.